Okay, and that is figuring out when an object changes directions. Okay, so when you're talking about motions of a particle along a line, it can be moving in the positive direction or the negative direction. But it can obviously slow down and then start going in the other direction. If you think of throwing an object up into the air, it gets to a highest point, and then it starts going the other way. So how do you know when a particle changes directions? Well, anybody have an idea what that criterion would be? Yeah.
When the velocity changes sign.
That's right. So the velocity changes sign, and you can look for it mathematically. That's exactly right, by looking for the place where the velocity is equal to 0. You know, it's like looking for a critical point in calculus. At the exact, I'll call it changeover point, the object's velocity is equal to 0. And so, for example, if you have like a position function that's just some random thing. Okay, question?
Couldn't a particle be moving, stop, but then continue moving? The velocity still equals 0, but it wouldn't change direction.
So you're right about that. So this is it's required that the velocity equals 0, but that's not sufficient necessarily. In most of the cases, you know, the most common cases we deal with are constant acceleration, and in that case, it's necessary and sufficient. So, I mean, it's if you find it, then that's the point. With a more complicated thing like this, where you just have some random function, you know that if it changes directions, the velocity has to equal 0, but you need to do a little further digging. So the candidates for times of direction change are, you take the derivative of that. So v of t is equal to -3 sine of t, and set that equal to 0. And those would give you the candidates for the changeover points. You'd have to look a little farther with a complicated function like this. Okay, but more often what we're going to do is, like, if a ball starts rolling up a ramp, you know, how high until it starts rolling back down. And that, if you look for a time when velocity is equal to 0, you're only going to get one time because it's constant acceleration. And that time is going to be the time when it instantaneously comes to rest and then starts going back the other way. And then another velocity is if another example is if you throw an object up into the air, you know, eventually it's going to get to this highest point. Okay, so let me do one example problem with a ball thrown up into the air, but the strategy is the same for all of these kind of things. So let's say a ball is thrown upward at 2 meters per second from the ground level. What's the highest point it reaches? So I'll choose time equals 0 to be when it's thrown. Time final is going to be when it reaches the highest point, because that's the instant where we're looking for something. P equals 0 is going to be the ground. Positive direction is going to be up. And then the values, let's see, time final, we don't know that. Position when time is equal to 0, it's at ground level, so that's 0. P final, that's what we're looking for. Velocity when time is equal to 0 is 2 meters per second up, so that's positive 2. V final, so this is where we're going to use that criterion. If it's, when it gets to the highest point, the velocity is equal to 0, so at time final, the velocity is equal to 0. And then the acceleration, this is free fall, so 9.81 meters per second down, so negative 9.81 meters per second squared. And now we're looking for a one equation that works with all of this. So we'd like to find P final. Is there an equation that we can use to find P final from what we have? Yep. The first equation, we don't know P final and we don't know T final. So I think the one we need is the one that doesn't have time in it, you know, since we don't know time and we don't care about it. So I think this one should work. 2a times quantity P final minus P0 is equal to V final squared minus V0 squared. So negative 19.62 times P final minus 0 is equal to 0 squared minus 2 squared. And so negative 19.62 P final is equal to negative 4. The negatives cancel. And if you divide that out, could anyone have a calculator in front of them? What's 4 divided by 19.62? 0.2038. Okay, I'll just go with that. So 0.20, not very far because it's not very high up in the air because it wasn't going very fast. Okay, so there's at least one problem on the homework where you have to do that. Any questions about that idea?